All right, we are in section 5.6, finding rational zeros. This section deals with what is called the rational zeros theorem. And if you have a function that is a polynomial and it has integer coefficients, then every rational zero can be listed as the following. It says p divided by q, where p represents the factors of constant terms, and q is the factors of the lead coefficient. Now, if you didn't hear what I was talking about in class, finding the zeros. So it's like, imagine like this is an XY coordinate here, and then let's make this in red. So what I'm gonna have in red here is a function. Okay, this is something you might see on the graph, and each spot here where it intersects the x-axis, what these points represent is those are values when our function equals 0. So for this particular function that I drew, it has 1, 2, 3, 4, 5 real zero solutions. And for the most part, we can find them on the graph, but there is also a list of possible rational zeros, and we can find them all by using this format as long as our coefficients are integers. So if we look here in our examples, what we're looking for is we're going to use the rational zeros theorem to list all the possible zeros. So for example A, I have x to the fourth plus 6x cubed minus 5x squared minus 9x plus 16. So if I'm going to use the p over q theorem, so p represents the factors of constant term. Well, the constant term is 16. The constant term is the one that doesn't have any variables attached to it. And then q is the factors of the leading coefficient. Leading coefficient is the largest one is the power 4, and that happens to have a coefficient of 1. So when I list all the possible factors, I can use both positive and negative. So for 16, the factors of 16 would be plus or minus 1, plus or minus 2, plus or minus, can't be 3, but it can be 4, plus or minus 8, and plus or minus 16. Now looking at the bottom, it can just be plus or minus 1. And since all I have down there in my denominator is 1, so my list of possible zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and then plus or minus 16. But for B, we have g of x equals 6x cubed plus 8x squared minus x minus 9. So if we use our p over q theorem, we have p would be 9 and q would be 6. So we have to find the factors of 9 and the factors of 6. So for the top, I can say plus or minus 1. I can't say it's 2, but plus or minus 3 and plus or minus 9 are the factors of 9. For 6, it would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, since my denominator doesn't just have a 1, I have to divide each one out and create my list. So first off, I'm just going to pay attention to my plus or minus 1 in the numerator and then attach it to each of them in the denominator. So plus or minus 1 divided by plus or minus 1 just gives me a plus or minus 1. Plus or minus 1 divided by 2, plus or minus 1 half. Got plus or minus 1/3 and plus or minus 1/6. So that's, I'm done with the 1 here. So now let's go to the 3. So I got plus or minus 3, plus or minus 3 over 2, and I got 3 plus or minus 3 divided by plus or minus 3 gives me 1, but I already have a 1 here, so I don't have to repeat it. And I have 3 over 6, that's 1/2. I don't have to repeat that one either. So now I'm done with 3. So now I can go to 9. So that's plus or minus 9. And plus or minus 9 over 2. 9 divided by 3 is 3. That doesn't need to be repeated. And then 9 over 6 gives me 3/2, so that doesn't have to be repeated either. So the list of possible zeros for example B are right here. Okay? Now that we've talked about finding the list of possible zeros, I want to be able to show you how to find all the real zeros in a polynomial. Okay? Now, what I was telling you in class, having a graphing calculator is going to help you tremendously. I do have a download of how to get a graphing calculator to your computer or laptop, and if you're interested in doing that, that'll be on the website, so please check that out. I believe it's in the notes for this chapter. So here's what we're gonna do. I have 2x to the third minus 7x squared plus 9. So first thing I want to do is I want to make a list of all the possible rational zeros using the rational zeros theorem. So my P over Q still again, and so my constant is 9 and my lead coefficient here is 2. So finding the factors of 9 and 2, so I have plus or minus 1, plus or minus 3, and plus or minus 9. For my denominator, it says plus or minus 1 and plus or minus 2. So if I were to take this, so starting with the 1, I got plus or minus 1, plus or minus 1/2. That's done. So plus or minus 3, plus or minus 3/2, plus or minus 9, and plus or minus 9/2. Okay, so those are the possible zeros that I could have for my real number zero solutions. So how I can determine what those are is I'm going to go to my graphing calculator, which is right here, and let's take a look. I'm just going to put it right here. I'm going to click it on, and I'm going to go to the y equals button so then I can graph a function. I'm going to clear out anything that was in there. So I'm going to type in this function. So I'm going to put 2, click on 2, and I'm going to go to x, and then it's to the third power minus 7x squared plus 9. And to the top right is I got my graph, and as I wait, I have, okay, so now I have my function, and it's in 1, 2, 3 spots. So I'm going to have 3 values for my real zero solutions. And how I can determine that is I can hover over to where it's located, and right here these are approximations. I'm not going to get exact values here, but it looks really close to -1. So if I right here. I'm going to write down -1 right here. Okay. Go back to my graph. Sorry. And click over to the next intersection. And that looks a lot like 1.5. And the other one looks like 3. So if I'm, so 1.5, so that's 3 over 2. And the other one was 3. So these values here, first I'm going to make sure, are they part of these solutions here? And they are. So to validate that these hold true, because again, those are approximations, and what I would like you to do to prove that these are solutions, not just because you were able to look them up on a graph, I want you to use synthetic division in order to prove that. So I want you to I'm going to take -1 to start with, and I'm going to take the coefficients of what I have in my function. So it's going to be 2, it's going to be -7, and I have a 0 for my x, and then 9. So what I'm going to do is perform my synthetic division. So I'm going to have 2, I got -1, so times by 2, so that's -2. Add those together, that's -9. Those together, that gives me 9. Add those together, that's 9, and that's -9. And so I got 0. Now this 0 is very, very, very important. If you get a value that has a remainder of 0, that means that negative, whatever this value here I use for the synthetic division, is a true statement, and it is a real 0 solution. So let's try the other ones. Okay, let's go 3 halves. And still go 2, -7, 0, 9. And all right, sorry about that. Okay, let's do the synthetic division for this one. So I'm gonna have 2. 2 times 3 halves is 3. And add those together, that gives me a -4. -4 times 3 halves gives me a -6. Add those together, gives me -6. Multiply -6 by 3 halves is a -9 and 0. So yep, holds true. And the last one, let's go 3. So I have 2, -7, 0, 9, 2. So that gives me 6, -1, -3, -3, -9, 0. Great. So those hold true. So my answers are -1, 3 halves, and 3. I'd like to see the synthetic division be done. I just don't want you to just put it on your calculator and then punch in the solution. I would like to see the synthetic division worked out, please. Okay. Let's look at B. So B, I have x to the 5th minus 3x to the 4th minus 5x third plus 15x squared plus 4x minus 12. So I'm going to list, I need to list the possible solutions. P divided by Q. And my lead coefficient, no, I'm sorry, my constant is 12, and my lead coefficient is 1. So I don't have to deal with the denominator, I just have to deal with the numerator. So my possible solutions are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So those are the list of the possible solutions. So if I were to if I were to graph this function, I turn it on. let's clear this out and type in, let's see here, type in our function, so it'd be what, x to the fifth minus 3x squared to the fourth minus 5x to the third plus 15x squared plus 4x minus 12. It's really important to make sure that you type it in correctly. And as it's thinking, I have my graph. So it looks like it's what, 1, 2, 3, 4, 5 different intersections. So it looks like 3, looks like 2, 1, -1, and -2. So if I were to rewrite these solutions here, and what we're going to do is we'll say that it's -2, -1, 1, 2, and 3. And if we look, are they part of those solutions, of the possible solutions that are in here? And yes, they are. And we can prove that by using synthetic division. So I'm gonna show you what 1 looks like. So if I have, let's look at -2. So I got -2, and so I'm gonna have 1, -3, -5, 15, 4, -12. So let's go. So let's go 1. That's -2. And that would be what, -5. That's +10, +5, -10 becomes what, -5? No, I'm sorry, +5. And this is what, -10, -6, +12, and then 0. So we got the 0, holds true. And if you were to do it to the rest of them, I'm sure they would hold true as well. So those are the answers for example B. Let's look at my last. I want to get some room to work. Okay. What I'm going to do is I'm going to list possible zeros. So let's get started. So the P over Q. My P here would be 14. And Q is 2. So it's ±1. ±2, ±7, and then ±14. Down here is ±1, ±2. So the list of possible ones would be ±1, ±1/2, ±2, and then ±1 is repeated, ±7, ±7/2, and ±14. So let's graph this. Take a look what it says. Let's go to the y equals, clear out. And so I'm going to type in 2, oh, sorry. Let's go back. Let's go x to the third power. Sometimes I make a mistake. Plus 5x to the second minus 11x minus 14. And we're going to graph it. And what it looks like is I got 3 of them. So I have, looks like 2 and -1. And it looks like -3.5. So, but -3.5 I think is -7/2. So, I'm going to say that my answers are -7/2, -1, and 2. And by using static division, that those would be proven valid. Okay, and then is how we find real value zeros while using the rational zeros theorem. Hope this helps. Until next time.